Hello friends, today's topic is overfitting and underfitting in machine learning. See, this is the x-axis diagram. This is these are the data sets, and this is the median. This is the underfitted, and this is the good fit, robust, and this is a overfitted. Underfitted means the data sets. Most of the data sets are far from the median. Okay, and in good fit, the values of data sets are nearby the median. Okay, and the overfitted, the all values of data sets are over the median line or nearby the median. So overfitting and underfitting are the two main problems that occur in machine learning and degrade the performance of the machine learning models. Here, generalization defines the ability of a machine learning model to provide a suitable output by adapting the given set of unknown inputs. It means after providing training on the data set, it can produce reliable and accurate output. Hence, the underfitting and overfitting are the two main terms need to be checked for the performance of the model and whether the model is generalized well or not. You have to check whether the model is generalized or not. So before understanding the overfitting, let us understand some basic terms that will help to understand this topic also well. First is signal. It refers to the true underlying pattern of the data that helps the machine learning model to learn from the data. Noise. Noise is unnecessary and irrelevant data that reduce the performance of the model. Bias. Bias is a prediction error that is introduced in the model due to the oversimplifying the machine learning algorithm, or it is the difference between the predicted value and the actual values. Variance. If the machine learning model performs well with the training data set, but does not perform well with the test data set, then variance occurs. So now what is overfitting? The overfitting occurs when our machine learning model tries to cover all the data points or more than the required data points present in the given data set. Because of this, the model starts caching noise and inaccurate values present in the data set. And all these factors reduce the efficiency and accuracy of the model. The overfitted model has low bias and high variance. The chances of occurrence of overfitting increase as much we provide training to our model. It means the more we train our model, the more chances of occurring the overfitted model. See, if you train your data and if you train your data and to create a model and number of features you have trained, but there is a requirement of 2-3 features and you have trained 10 features, then it means it is a overfitted model, because you have trained lots of features, but there is a requirement of a particular model is 2-3 features, and it means it is overfitted. Overfitting is the main problem that occurs in supervised learning. The chances of occurrence of overfitting increase as much we provide training to our model. It means the more we train our model, the more chances of occurring the overfitted model. For example, the concept of overfitting can be understood by the blow graph of linear regression output. These are the data, okay, and this is the line which crosses all data sets. As we can see from the above graph, the model tried to cover all the data points present in the scatter plot. It may look efficient, but in reality, it is not so. It is not possible कि all data are covered in a single line. It is not so because the goal of the regression model to find the best fit line. But here we have not got any best fit, so it will generate the prediction error. Okay. So how to avoid the overfitting in model? Both overfitting and underfitting cause the degrade performance of the machine learning model, but the main cause is overfitting. So there are some ways by which we can reduce the occurrence of overfitting in our model. First is cross-validation, training with more data, removing features, early stopping the training, regularization, and assembling. Underfitting. Underfitting occurs when our machine learning model is not able to capture the underlying trend of the data. To avoid the overfitting in the model, the fed of training data can be stopped at an early stage, due to which the model may not learn enough from the training data. As a result, it fails to find the best fit of the dominant trend in the data. In the case of underfitting, the model is not able to learn enough from the training data, and hence it reduces the accuracy and produce the underlying unreliable prediction. So an underfitted model has high bias and low variance. So we can understand the underfitted using below output of the linear regression model. These are the data points or data sets, and this is a median line which we can draw a line. And you can see most of the data sets are far from this line, in the median line. Okay, so this is the underfitted, because we have to try a line where all data sets are nearby the median. Goodness of fit. The goodness of fit term is taken from the statistics, and the goal of the machine learning model to achieve the goodness of fit. In statistics modeling, it defines how closely the result or predicted values match the true values of the data sets. The model with a good fit is between the underfitted and overfitted model, and ideally it makes prediction with zero errors. But in practice, it is difficult to achieve it, as when we train our model for a time, the error in the training data go down, and the same happens with the test data. But if we train the model for a long duration, then the performance of the model may decrease due to the overfitting. As the model also learns the noise present in the data set, the errors in the test data set start increasing. So the point just before the raising of errors is the good point, and we can stop here for achieving a good model. There are two other methods by which we can get a good point for our model, which are the resampling method to estimate model accuracy and validation datasets. Thank you.